Hello, this is now DGQ1 discussion. So I'm back, mostly rejuvenated, and yeah, there is some problem with integral terms. I mean, things are clear, but there are a few details to check here and there. But yeah, otherwise it's nice. Let's start submanifolds. Right, this is a very important topic, and it keeps coming everywhere. Right, it's good to really master this topic. Yeah. So I have my millet roti on the side. Just keep munching in between. Yeah. So yeah, let's start. So the first theorem here is I'm whiffing so badly at typing. Oof. Okay, the first theorem is basically inverse function theorem for manifolds. Theorem inverse function theorem for manifolds. So let f m to n be a smooth map, then if f star at p from tpm to tf of p n is an isomorphism, then there exists a neighborhood of p, neighborhood v of p, and a neighborhood u containing f of p such that f of v is actually u, right, and f from v to u is a diffeomorphism. Is a diffeomorphism. Very good. So basically the proof involves the fact that f star locally given by the Jacobian of f is if it's isomorphic, then it's invertible, then the Jacobian is invertible. So locally through inverse function theorem you will find a neighborhood, right? So what you're trying to say is if f star, not that f may not be a bijection, so it may not be true globally, right? So if f star p from tpm to t f of pn is an isomorphism, what we're trying to say is for all p, this is an isomorphism at p. First statement is that at p, then you can find around p neighborhood. This is a simple local statement of simple generalization of inverse function theorem in Euclidean spaces. Then f star P is an isomorphism for all P. For all P in M, then F is a local diffeomorphism. Perfect. What next is that if it's a bijection, if F is a bijection and F star TPM to df of P and is an isomorphism, for all P in M, then F is a diffeomorphism. This is a very important result that keeps coming everywhere. This is basically inverse function theorem, and I have an undefined control sequence. Where do I have it? Yep, cool. Very nice. Let's look at the proof. It is again basically it relies on the inverse function theorem locally in the local equilibrium spaces. So okay, let's go. Suppose okay, so we are proving that in all cases basically F star is a isomorphism, so we will of course take the dimension to be same. Dim M equals to dim N, and let V comma psi be a chart centered at F of P, and U comma phi be a chart centered at P. It's clear where the charts are, right? Now then G equals to psi composed with F composed with phi inverse, which is from phi of U to psi of V, right? It's good to keep track of the Euclidean spaces also. Rn, it's an Rn to Rn map such that G of 0 is actually 0. Then has an invertible Jacobian matrix J G O because because f star is injective. Injective. So by inverse function theorem, Euclidean spaces, there exists u0 prime subset of phi of u and is containing 0 such that v underscore equals to the image of this is also open in psi of v and g prime to v0 prime is a diffeomorphism. This is the standard Euclidean space thing. Cool. Then yeah, then yeah, f equals to psi inverse composed with g composed with phi from u0, which is to v0 prime diffeomorphism. define what are regular submanifolds. Let n be a smooth n manifold and M is a subset of n, then M is called a regular submanifold of dimension k of n if for any p in M there exists a chart u comma phi of n such that u intersection m, right? So basically there's a chart in M such that the chart of n such that its u chart interaction with M for any p in this manifold, this subset M, potentially regular submanifold, the points in M and u in intersection of these two sets is precisely a form phi inverse of x1 comma xn such that xn phi of u such that x k plus 1 equals to xn equals to 0. So basically last k so last n minus k are 0. Yep, see. Yep. Okay, so that is the definition. Okay, I need to put an image for both this definition, and this is basically a prototype of, okay, the definition of regular submanifold is basically a prototype of a Euclidean of Rk living inside Rn. Cool. That is fine. But we now want to put some images here. Just some maps, right? Also add a fruit salad in the evening. It was nice. It is finally good that I can just go and have fruit salad. Wow. Things would have been so much better if it was there from earlier. But well, thankfully it's here, so cool. Let me load some figures are loaded. Fig H IFT G well IFT, and then here H reg sub G. Cool. Bit of terminology. Let's just say remark. N minus k equals to dim of m minus dim of m is called the codimension of the submanifold M. Adapted charts. Yeah. What we need to check is these charts indeed cover the whole potential manifold M, and also there's a charts on this. Okay, so you can cover M by charts satisfying the of property let phi m u cap m to rk phi m of q equals to phi q phi k of q basically phi m from u cap m to phi m of u cap m is continuous bijection and pool, and u comma 5 is called an adapted chart of M apparently. Now we check for smoothness. Okay, let u comma 5 standard protocol v comma psi be two adapted charts of M, and then it's basically what? Then it's basically okay. Adapted charts. Okay. Okay, so what we want is phi m composed with sine inverse from phi of u intersection v intersection m to psi of u intersection v intersection m, and then we need to show that this is smooth. What is this basically? This is subset of Rk. This is subset of Rk, right? X1 is equal to xk inverse, then yeah, basically phi inverse of x1 or xk comma 0 is 0, right? So it's precisely that, and then you take a phi of this, right? So basically phi 1 which is basically smooth. Yeah, so H2
plante T 2 pièces
les chats blancs.
les chats blancs
Ma maison a 4 pièces. Les pièces.
Les tables blanches.
ouvre ouvert ouvre
Ouvre.
les voitures blanches
Ouvre.
les vélos blancs Chaise.
Chaise.
Il y a 4 chaises dans le salon de Paul. Il a 2 sœurs et 2 frères. Ils sont 5. C'est beaucoup. Ils mangent dans le jardin. Eh. Beaucoup.
Blanc.
Ma maison.
Maison. Ah.
4
4
pièces.
pièces. Ouvre, ouvre, ouvre. Ouvre.
Chat blanche.
Ah. Salon. Salon. 1, 2. Salon. Don. Ma. Maison. Arbre.
I'm just doing a Duolingo lesson because my pencil is traveling.
5. Fromage. Fleurs.
Salade. Des. Des. Ils ouvrent les portes.
Ils ouvrent les portes.
Elles ouvrent les fenêtres.
Elles ouvrent les fenêtres.
Deux arbres et une fleur. Frère, fleur.
1, 3. Arbre. Arbre.
Il y a 3 arbres.
Nous habitons en France. Nous avons des vaches et un cheval. Les vaches.
Avons.
Nous habitons en France. Nous avons des vaches et un cheval. Les vaches sont.
Vache.
Nous habitons en France. Nous avons des vaches et un cheval. Les vaches sont gentilles. Le cheval est gentil aussi.
Il y a 3 fenêtres. Il ouvre la porte. Ouvre.
Ouvre.
Okay, apparently there's palak dal in the canteen and I want to go, but this is almost done, so I'll just go before 9. Okay. Just tap the image. Cool. So the fig goes here. Reg atlas.jpg. Reg atlas. So what we want to show is that we want to show psi m composed with phi m inverse from phi of u cap v cap m to psi of u cap v cap n, sorry, m. Is smooth. It is indeed, it is given by psi m sub phi m inverse of x1 dot xk well you need to are going to arc here, right? Yeah, phi m is indeed an arc here. Yeah, basically. Yeah, I mean that part is just smooth, right? Smooth. So we have proposition that a regular submanifold has a unique smooth structure where the adapted charts form an atlas. Cool. as a regular submanifold of some array of some t. Let's see some examples. Cool. Okay, this is getting full box. So how do we do it? So what can we remove? Okay. What? Okay. How do okay, so examples include, first example is that M is an n manifold. Manifold U, n is an U subset of M is an open subset. Then U is a regular submanifold of dimension n. Moreover, if n set of M is a regular submanifold of dimension k, then n is essentially an open subset of M. So submanifolds of codimension 0 are just open subsets. next example would be of RK cross 0 set of Rn. The 0 is in Rn minus k, apparently. Rn is a submanifold of mk. That is cool. Then we have now consider -1 plus consider -1, 1 is a submanifold of R2 of dimension 1. Whenever we can have images, we should have images. Simple find out. फिर से वाइड क्या हो गया यार? This is wide. And then we can consider some non-examples. Consider x equals to x comma y in R2 such that xy equals to 0 comma x comma y greater than equal to 0 is not a regular submanifold of R2. Why is it so? It's not a regular submanifold of R2. Anyways, why is it not? Well, wait, how do you show that this is not a submanifold of R2? One should actually check this properly. Yeah, this is actually not a submanifold of R2 because yeah, there is some involved, and x equals to x, y, z in R3 such that x square plus y square equals to z square. Z is not a submanifold of R3. Although it's not really a good diagram, but so that's it. We'll end with this picture. Yeah, cool. We'll end with this, and the next lecture is on important concepts like critical points and regular points. Critical value, regular points, regular value, which gives a good characterization of regular manifolds. So that's the next part, and okay, that's it.